This article lists and discusses the usage and derivation of names of large numbers, together with the possible extensions. The following table lists those names of large numbers that are found in many English dictionaries and thus have a special claim to being real words. The traditional British values shown are unused in American English and are becoming rare in British English, but there are other language variants are dominant in many non-English speaking areas, including continental Europe and Spanish-speaking countries in Latin America. See long and short scales. English also has many words, such as zillion, used informally to mean large but unspecified amounts. See indefinite and fictitious numbers. Standard dictionary numbers. Apart from million, the words in this list ending with illion are all derived by adding prefixes to the stem million. Centillion appears to be the highest name ending in illion that is included in these dictionaries. Trigentillion, often cited as a word in discussions of names of large numbers, is not included in any of them, nor are any of the names that can easily be created by extending the naming pattern. All of the dictionaries included googol and googolplex, generally crediting it to the Kastner and Newman book and to Kastner's nephew. None include any higher names in the googol family. The Oxford English Dictionary comments that googol and googolplex are not in formal mathematical use. Origins of the standard dictionary numbers. The words bimillion and trimillion were first recorded in 1475 in a manuscript of Jet and Adam. Subsequently, Nicolas Chuquet wrote a book, Tripartie en la science des nombres, which was not published during Chuquet's lifetime. However, most of it was copied by Estienne de la Rochefort, a portion of his 1520 book, L'Arithmétique. Chuquet's book contains a passage in which he shows a large number marked off into groups of 6 digits, with the comment, "Au qui vaut le premier point peut signifier million, le second point billion, le tiers point trillion, le quadrillion, le cinquillion, le sixillion, le sept. Septillion, le hyptotillion, le neuf non-illion et ainsi des autres chez plus ultron voluit procedere." Chuquet is sometimes credited with inventing the names million, billion, trillion, quadrillion, and so forth. This is an oversimplification. Million was certainly not invented by Adam Chuquet. Million is an old French word thought to derive from Italian milione, an intensification of mille, 1,000. That is, a million is a big thousand. For the way in which Adam and Chuquet used the words, it can be inferred that they were recording usage rather than inventing it. One obvious possibility is that words similar to billion and trillion were already in use and well known, but that Chuquet, an expert in exponentiation, extended the naming scheme and invented the names for the higher powers. Chuquet's names are only similar to, not identical to, the modern ones. Adam and Chuquet used the long scale of powers of a million, that is, Adam's bimillion denoted 1012, and Adam's trimillion denoted 1018. The googol family. The names googol and googolplex were invented by Edward Kastner's nephew, Milton Sirota, and introduced in Kastner and Newman's 1940 book, Mathematics and the Imagination. In the following passage, the name googol was invented by a child who was asked to think up a name for a very big number, namely 1 with 100 zeros after it. He was very certain that this number was not infinite, and therefore equally certain that it had to have a name. At the same time that he suggested googol, he gave a name for a still larger number, googolplex. A googolplex is much larger than a googol, but is still finite. As the inventor of the name was quick to point out, it was first suggested that a googolplex should be 1, followed by writing zeros until you got tired. This is a description of what would actually happen if one actually tried to write a googolplex. But different people get tired at different times, and it would never do to have Carnera, a better mathematician than Drive Einstein, simply because he had more endurance. The googolplex is then a specific finite number equal to 1 with a googol zeros after it. Conway and Guy have suggested that nplex be used as a name for 10n. This gives rise to the name googolplex for 10 googolplex. This number is also known as a googol-duplex and googolplexion. Conway and Guy have proposed that n-minix be used as a name for 10-n, giving rise to the name googominix for the reciprocal of a googolplex. None of these names are in wide use, nor are any currently found in dictionaries. The names Google and googolplex have inspired the name of the Internet company Google and its corporate headquarters, the Googleplex, respectively. Extensions of the standard dictionary numbers. This table illustrates several systems for naming large numbers, and shows how they can be extended past vigintillion. Traditional British usage assign new names for each power of 1 million. 1 million equals 1,000,000. 0002 equals 1,000,000,000. 0003 equals 1 trillion, and so on. It was adapted from French usage, and is similar to the system that was documented or invented by Tukey. Traditional American usage, Canadian, and modern British usage assign new names for each power of 1,000. Thus, a billion is 1,000 times 10,000 and 2 equals 109. A trillion is 1,000 times 10,000 and 3 equals 1012, and so forth. Due to its dominance in the financial world, this was adopted for official United Nations documents. Traditional French usage has varied. In 1948, France, which had been using the short scale, reverted to the long scale. The term milliard is unambiguous and always means 109. It is almost never seen in American usage, rarely in British usage, and frequently in European usage. The term is sometimes attributed to French mathematician Jacques Pelletier du Mans circa 1550, but the Oxford English Dictionary states that the term derives from post-classical Latin term miliatum, which became milia and then miliat and finally our modern term. With regard to names ending in iliad for numbers 106 and +3, milliard is certainly in widespread use in languages other than English, but the degree of actual use of the larger terms is questionable. The terms milliard in German, Milliard in Dutch, milyar in Turkish and in Russian are standard usage when discussing financial topics. The naming procedure for large numbers is based on taking the number and occurring in 103n plus 3 or 106n and concatenating Latin roots for its units, tens, and hundreds placed together with the suffix zillion. In this way, numbers up to 103,999 plus 3 equals 103,000 to 106,999 equals 105,994 may be named. The choice of roots and the concatenation procedure is that of the standard dictionary numbers if n is 20 as smaller, and, for larger n, is due to John Horton Conway and Richard K. Guy. When preceding a component marked s or x, tre changes to tres, and che to ses or sex. Similarly, when preceding a component marked m or n, septe and nov change to septem and novem, or septen and noven. Since the system of using Latin prefixes will become ambiguous for numbers with exponents of a size which the Romans rarely counted to, like 106,258,000, Conway and Guy have also proposed a consistent set of conventions which permit, in principle, the extension of this system to provide English names for any integer whatsoever. Names of reciprocals of large numbers do not need to be listed here, because they are regularly formed by adding the, g, quatu or decillionth, centillionth, etc. For additional details, see billion and long and short scales. Binary prefixes. The International System of Quantities defines a series of prefixes denoting integer powers of 1024 between 10,241 and 10,248. Proposals for new naming system. In 2001, Russ Rowlett, director of the Center for Mathematics and Science Education at the University of North Carolina at Chapel Hill, proposed that, to avoid confusion, the Latin-based short scale and long scale systems should be replaced by an unambiguous Greek-based system for naming large numbers that would be based on powers of 1,000. Other large numbers used in mathematics and physics: Avogadro's number, Graham's number, Skewer's number, Steinhaus-Moser notation.